Cosmic background radiation is the oldest light in the universe, dating back to just 380,000 years after the Big Bang. Take a moment to let that truly sink in. This ancient light has been traveling through the vast expanse of space for over 13 billion years. Imagine the journey these photons have taken, crossing incomprehensible distances, witnessing the birth of galaxies, the formation of stars, the creation of worlds. All of this ancient light still journeying through the cosmos, still reaching us today. This radiation is called the cosmic microwave background, or CMB, because it is strongest in the microwave part of the spectrum. It exists in a part of the electromagnetic spectrum that our eyes cannot perceive. Invisible to our eyes, yet detectable by sensitive instruments that can tune into these ancient wavelengths. These microwaves carry with them the story of our universe's beginning. The CMB is everywhere, filling the entire universe with a soft, uniform glow. Like a gentle blanket of light wrapping around everything that exists. From the smallest atom to the largest galaxy cluster, this ancient radiation bathes everything in its subtle presence. It is truly omnipresent, a cosmic ocean of light that we float within. It is so faint that it can only be detected by sensitive radio telescopes. A whisper so quiet, you need the most delicate instruments to hear it. The CMB represents just a few degrees above absolute zero in temperature, making it one of the coldest things in the universe. Yet this faint signal carries within it profound secrets about the nature of reality itself. The CMB is a remnant of the hot, dense plasma that filled the early universe. Long ago, when the universe was young, it was filled with tremendous energy and brilliant light. Everything was closer together, compressed into a space far smaller than it is today. The temperature was unimaginably high, and matter existed in a state unlike anything we see in the universe today. When the universe cooled enough, atoms formed and light could finally travel freely. This was a pivotal moment in cosmic history, when the universe transformed from opaque to transparent. Before this moment, photons could not travel far before colliding with free electrons. But once atoms formed, light was liberated, free to journey across the expanding cosmos. That first light is what we now see as the CMB, the very first photons to journey across the cosmos, now reaching us as a gentle microwave glow. These are the same photons that broke free all those billions of years ago, stretched and cooled by the expansion of space itself, but still carrying their ancient message. The CMB is almost perfectly uniform, with only tiny variations in temperature, like a calm sea with only the slightest ripples on its surface. This uniformity is remarkable, telling us that the early universe was extraordinarily smooth and homogeneous. It speaks to a fundamental simplicity in the cosmos's beginning. These tiny variations are like ripples in a pond, showing where matter was slightly denser. These small differences, barely perceptible, would grow over billions of years. They are the seeds from which all structure would emerge, eventually forming the galaxies and stars we see today. From these quantum fluctuations came everything we know. The CMB temperature is about 2.73 Kelvin, just a few degrees above absolute zero. It is profoundly cold, colder than the darkest depths of space. yet it fills the entire universe with its presence. A gentle cosmic chill, drifting through the endless void, touching everything that exists with its ancient coolness. The CMB was first predicted in the 1940s by George Gamow, Ralph Alpha, and Robert Herman. Three brilliant scientists looking backward through time with the power of mathematics and physics. They were imagining the earliest moments of our universe, trying to understand what conditions must have existed in those first fractions of a second after the Big Bang. They estimated the temperature to be around 5 Kelvin, close to the actual value. Their predictions were remarkably accurate, a testament to the power of mathematical reasoning and theoretical physics. Using nothing but equations and logic, they were able to predict something that wouldn't be observed for another 2 decades. The CMB was accidentally discovered in 1964 by Arno Penzias and Robert Wilson at Bell Labs. Sometimes the greatest discoveries in science come when we least expect them. They were working on satellite communications, trying to eliminate sources of noise from their antenna. Little did they know, they were about to stumble upon one of the most important discoveries in the history of cosmology. They found a mysterious, steady noise in their radio antenna that could not be explained. A persistent hum, present day and night, refusing to go away no matter what they tried. They cleaned their antenna, they checked their equipment, they looked for every possible source of interference. But the noise remained, constant and unchanging. This noise was the same in every direction, day and night. No matter where they pointed their antenna, whether toward the center of our galaxy or away from it, whether during the day or in the middle of the night, the signal remained absolutely constant. This was deeply puzzling to them. The noise was not from the Earth, Sun, or our galaxy, but from the entire universe. It came from everywhere at once, a truly universal background hum. Once they realized what they had found, the implications were staggering. They had detected the afterglow of the Big Bang itself, the ancient light that filled all of space. Penzias and Wilson shared the 1978 Nobel Prize in Physics for their discovery. Their accidental finding transformed our understanding of the cosmos. What began as a frustrating technical problem became one of the most profound discoveries in the history of science, confirming theories that had been debated for decades. Their finding provided strong evidence for the Big Bang theory. It was observational confirmation of a theory that had been proposed but not yet proven. The existence of this background radiation was exactly what the Big Bang theory predicted. It was a critical piece of evidence that changed cosmology forever. Before the CMB, the steady-state theory was a rival explanation for the universe's origin. The steady-state theory proposed that the universe had always existed, unchanging and eternal, with new matter continuously being created to maintain a constant density as space expanded. It was an elegant idea, but it made different predictions than the Big Bang theory. The CMB helped settle the debate in favor of the Big Bang. This ancient light became proof that our universe had a beginning, a moment of creation approximately 13.8 billion years ago. The steady-state theory could not explain the existence of this uniform background radiation, and gradually the scientific community converged on the Big Bang as the best explanation for the universe we observe. The CMB has a nearly perfect blackbody spectrum, matching predictions from quantum physics. It is one of nature's most elegant phenomena, a textbook example of how matter and energy behave at thermal equilibrium. The spectrum fits theoretical predictions with extraordinary precision. This means the radiation was once in thermal equilibrium, like a glowing oven. Long ago, the entire universe was like a perfect furnace, uniformly hot and bright. Every region of space was at the same temperature, with matter and radiation in perfect balance. This equilibrium is reflected in the spectrum we observe today. The CMB spectrum is the most precisely measured blackbody in nature. No laboratory experiment, no matter how carefully controlled, can match its perfection. The universe itself created the ideal blackbody, a natural experiment operating on the largest possible scale. The precision of this spectrum is truly remarkable. Tiny irregularities in the CMB reveal the seeds of all cosmic structures. These small variations, these quantum fluctuations in the early universe, held the blueprint for everything that would come later. They determined where galaxies would form, where great voids would emerge, where clusters would gather. These seeds grew into galaxies, clusters, and the cosmic web. From tiny fluctuations, barely 1 part in 100,000, immense structures emerged over billions of years. Gravity amplified these small differences, pulling matter together, creating the vast tapestry of structure we observe in the universe today. The CMB's patterns match predictions from inflation theory. Inflation was a period of extremely rapid expansion that occurred just after the Big Bang. In less than a second, a fraction of a second, the universe grew exponentially larger. This brief but dramatic expansion left an imprint on the cosmic microwave background. The CMB is a direct probe of the universe's first moments. It gives us a window into a time before stars existed, before galaxies had formed, before any complex structure had emerged. It shows us the universe in its infancy, simple and smooth, just beginning its long journey of evolution. Its temperature is the same in all directions to within 1 part in 100,000. This incredible uniformity tells us something profound about the universe's beginning. It suggests that the early universe was in a state of remarkable homogeneity, with conditions nearly identical across vast distances. This uniformity is evidence that the universe was once much smaller and hotter. Everything we see today, all the galaxies and stars and planets, all of it was once compressed into an unimaginably small space. The fact that the CMB is so uniform tells us that this compressed state allowed different regions to reach thermal equilibrium. And from that hot, dense beginning, the universe has been expanding and cooling for over 13 billion years. The CMB is the gentle echo of that expansion, a reminder of where we came from. It connects us to the earliest moments of cosmic history, a fossil record written in light itself. The CMB was mapped in detail by NASA's COBE satellite in the 1990s. The Cosmic Background Explorer satellite was launched specifically to study this ancient radiation. From its orbit high above Earth's atmosphere, COBE gazed out at the entire sky, measuring the ancient light with unprecedented sensitivity. COBE measured the large-scale anisotropies, or ripples, in the CMB. These ripples were invisible to the naked eye, variations of only a few millionths of a degree. But COBE could see them clearly, mapping out the pattern of slightly warmer and slightly cooler regions across the entire sky. These ripples were the first evidence of structure in the early universe. They revealed that even in the universe's infancy, when it was only 380,000 years old, tiny differences existed from place to place. These were the primordial density fluctuations that would eventually grow into all the structure we see today. The COBE team won the 2006 Nobel Prize in Physics for their work. Their maps of the CMB transformed cosmology, revealing secrets that had been hidden for billions of years. The principal investigators, John Mather and George Smoot, were recognized for their groundbreaking contributions to our understanding of the universe. Later missions like WMAP and Planck refined the maps further. The Wilkinson Microwave Anisotropy Probe, launched in 2001, and the Planck satellite, launched in 2009, each brought sharper vision and greater sensitivity. Each new satellite revealed more detail in the cosmic background, like a photographer using a better camera to capture finer features. Planck measured the CMB with even greater precision than any previous mission. Its maps showed the universe's earliest structures with stunning clarity, resolving features at scales that COBE and WMAP could not distinguish. The level of detail is extraordinary, allowing cosmologists to test theoretical predictions with unprecedented accuracy. These maps reveal the geometry and composition of the universe. They tell us what the universe is made of, how much ordinary matter exists, how much dark matter, how much dark energy. They reveal the shape of space itself, the curvature of the cosmos on the largest scales. The CMB shows that the universe is flat or nearly so, not curved like a sphere or saddle-shaped like a hyperbolic surface, but stretched out like an infinite plane. This flatness is one of the key pieces of evidence supporting the theory of cosmic inflation. It also reveals the amounts of dark matter and dark energy. The precise patterns in the CMB allow scientists to determine that ordinary matter makes up less than 5% of the universe's total energy. Dark matter contributes about 27%, while dark energy dominates with about 68%. The universe is mostly made of things we cannot see, mysterious substances we are still learning to understand. The CMB is a key tool for measuring the age of the universe. By studying this ancient light, by analyzing its spectrum and its fluctuations, cosmologists can determine that our universe is 13.8 billion years old, give or take a few tens of millions of years. Ancient beyond human comprehension, yet we can measure its age with remarkable precision. The CMB is a fossil, preserving the state of the universe at recombination. Like a snapshot frozen in time, it shows us a moment from the distant past. Just as paleontologists study fossils to learn about ancient life, cosmologists study the CMB to learn about the early universe. Recombination is when electrons and protons joined to form neutral atoms. This was a transformation, a phase transition, when the universe fundamentally changed its nature. Before recombination, the universe was a hot plasma. After recombination, it became a gas of neutral atoms. Before recombination, the universe was opaque to light. Photons could not travel far before scattering off free electrons. Light was trapped, constantly bouncing from one electron to another, unable to stream freely through space. The universe was like a thick fog. After recombination, light could travel freely through space. The universe became transparent, and light began its long journey across the cosmos. This was the moment of liberation, when photons broke free from constant scattering and could finally travel in straight lines across the expanding universe. The CMB is the first light to travel across the universe. These photons have been traveling for over 13 billion years, crossing vast expanses of space. They have journeyed from the era of recombination to the present day, witnessing the formation of every galaxy, every star, every planet that has ever existed. Its photons have been stretched by cosmic expansion to microwave wavelengths. Once they were high-energy gamma rays with wavelengths smaller than an atomic nucleus. But the expansion of space has stretched them, increasing their wavelength by a factor of about 1,000. What began as intense radiation has been cooled into gentle microwaves. The CMB is like a baby picture of the universe. It shows us what the cosmos looked like in its infancy, before it grew into the complex, structured universe we observe today. It captures the universe at its simplest, most homogeneous state. It shows us the universe when it was only 380,000 years old, a mere infant compared to its current age of 13.8 billion years. If the universe's current age were compressed into a single year, the CMB would show us the universe as it appeared in the first few hours of January 1st. The CMB is a gentle reminder of the universe's hot, dense beginning. It whispers to us about a time when everything was closer together, when temperatures were unimaginably high, when all the matter and energy in the universe was compressed into a space far smaller than it is today. It is a calm, quiet echo of the Big Bang, the reverberations of creation, still washing over us today, still detectable after all these billions of years. It is the fading sound of the universe's birth, still audible to those who know how to listen, still carrying information from the moment of cosmic genesis. The CMB is not perfectly smooth. It has tiny fluctuations, like the surface of a pond disturbed by the gentlest breeze. These variations are extraordinarily small, but they are real, and they carry profound information about the universe's earliest moments. These fluctuations are caused by density variations in the early universe. Some regions had slightly more matter, others had slightly less. These differences arose from quantum fluctuations during the inflationary epoch, tiny random variations that were stretched to cosmic scales by the rapid expansion. They are the seeds of all galaxies and clusters. From these tiny differences, barely perceptible in the early universe, all cosmic structures would eventually grow. The slightly denser regions would attract more matter through gravity, slowly building up over hundreds of millions of years. The fluctuations are mapped as temperature differences in the CMB, warmer spots and cooler spots, painting a picture of the early universe's density field. The pattern is complex and beautiful, a cosmic fingerprint that tells us about conditions in the primordial universe. The hottest spots are where matter was slightly denser. These regions would eventually collapse under their own gravity, becoming the birthplaces of galaxies. They mark the locations where matter began to clump together, where the process of structure formation began. The coldest spots are where matter was slightly less dense. These would become the great cosmic voids, vast regions with fewer galaxies. They represent the regions that matter flowed away from as gravity pulled it toward the denser regions. These differences are only about 1 part in 100,000. Incredibly small variations, barely detectable even with the most sensitive instruments. Yet these tiny differences determined the fate of the universe, shaping its evolution over billions of years. The CMB's fluctuations match predictions from inflation theory. The theory of cosmic inflation predicted a specific pattern of fluctuations, and the CMB confirmed them beautifully. The agreement between theory and observation is one of the great triumphs of modern cosmology. Inflation explains why the universe is so uniform. A brief period of rapid expansion, lasting less than a second, smoothed out the universe, stretching tiny regions to cosmic scales. This expansion made the universe remarkably homogeneous, while also creating the small variations we observe in the CMB. The CMB is a gentle fingerprint of the universe's birth. Each pattern in the microwave background tells a story about the cosmos's earliest moments, about quantum fluctuations and cosmic inflation, about the fundamental nature of space and time. It is a cosmic signature left behind by creation itself, a record of the universe's first moments. The CMB is the oldest light we can observe. Nothing we can see dates back further into cosmic history. It is the ultimate cosmic horizon, the edge of the observable universe in time. Before the CMB, the universe was opaque, and we cannot see back any further. It has been traveling for over 13 billion years, crossing incomprehensible distances, journeying through the expanding universe. These photons have traveled farther than anything else we can observe, coming to us from the edge of the observable universe. The CMB is a relic of the universe's infancy, a remnant from a time before stars existed, before planets had formed, before galaxies had assembled. It shows us the universe in its simplest state, before complexity emerged, before structure developed. It is a calm, ancient whisper from the dawn of time, speaking to us across billions of years, telling us about the universe's birth and early evolution. It carries messages from an era we can never visit, from a time we can only observe through this ancient light. The CMB is a gentle echo of the Big Bang. Like a sound that reverberates endlessly through a vast canyon, it carries the signature of creation. It is the afterglow of the cosmic explosion that gave birth to everything we know, still visible after all this time. It is a soft glow that fills the entire universe. Everywhere you look in the sky, If you had eyes that could see microwaves, the CMB would be there. A uniform background of ancient light, pervading all of space, connecting every point in the cosmos. The CMB is the background hum of the cosmos. Like white noise, like the static between radio stations, it is constant and ever-present. It fills the silence of space with its gentle signal, a cosmic ambient sound that never stops. It is a quiet reminder of our cosmic origins. We are all made of matter that was once part of that hot, dense, early universe. Every atom in our bodies, every particle that makes up the Earth and the Sun and the stars, all of it emerged from that primordial state. The CMB is a gentle, all-pervasive presence. You cannot escape it, for it fills all of space and time. Wherever you go in the universe, the CMB would be there, bathing you in its ancient light, connecting you to the earliest moments of cosmic history. It is the universe's oldest ambient soundscape. Though we call it sound, it is light, electromagnetic radiation transformed into microwaves by cosmic expansion. It is the universe's gentlest whisper, echoing through eternity, carrying messages from the beginning of time. The CMB is a fossil of the universe's hot, dense past. Like amber preserving an ancient insect, like ice preserving a mammoth, the CMB preserves information from long ago. It captures the state of the universe at a specific moment, freezing it in time for us to study billions of years later. It is a relic of the moment when the universe became transparent, when light finally broke free from the dense plasma, able to travel across the cosmos without constant scattering. This transition, this moment of liberation, is captured in the CMB we observe today. The CMB is a gentle, cold light that has cooled with the universe. As space expanded, the CMB cooled, redshifted from fiery gamma rays to gentle microwaves. The expansion of the universe stretched the wavelength of every photon, cooling the radiation degree by degree over billions of years. It is a soft microwave glow that permeates all of space. Invisible to our eyes, undetectable without specialized instruments, but filling every corner of the universe nonetheless. It exists in the spaces between galaxies, between stars, between planets, between atoms. The CMB is a calm, uniform background that covers the sky. Look in any direction, toward any constellation, toward the center of our galaxy or away from it, and you will find it there. Constant and unchanging, a cosmic constant that fills the heavens. It is a gentle, universal whisper from the Big Bang, the faintest of echoes, barely above the noise floor, yet carrying a message from the beginning of time. It speaks to us about cosmic inflation, about the hot, dense state of the early universe, about the fundamental nature of reality. The CMB is a quiet echo of the universe's creation. Like ripples spreading across a pond long after a stone has been thrown, it is the afterglow of the cosmic explosion. The initial flash has faded, but its light still reaches us, cooled and stretched by eons of expansion. It is a soft, ancient light that has traveled across time. From the universe's infancy to today, from an era 13.8 billion years ago to the present moment, these photons have journeyed without rest. They have crossed the entire observable universe to reach us. The CMB is a gentle, all-encompassing presence. It surrounds us completely, bathes everything in its subtle glow. A reminder that we exist within the universe, not separate from it. We are embedded in this ancient radiation, floating in an ocean of photons from the Big Bang. It is a calm cosmic background hum, always there, quietly humming at its characteristic frequency, the universe's constant companion. It has been there since the moment of recombination, and it will continue to exist far into the future, gradually cooling as the universe expands, drifting softly through the void. The CMB is a fossil of the universe's first light, the very first photons to travel freely through space, now reaching us after billions of years of journeying. They carry with them information about the conditions that existed when they were released, a snapshot of the universe at 380,000 years old. It is a relic of the moment when the universe cooled enough for atoms to form, a transition point, a critical threshold in cosmic history when the cosmos transformed from an ionized plasma to a gas of neutral atoms. This moment, called recombination, changed everything. The CMB is a gentle cold echo of the Big Bang. Though it began as intense high-energy radiation, it has cooled over eons of cosmic expansion. It has been redshifted from gamma rays to X-rays to visible light to infrared, and finally to the microwaves we detect today. It is a soft microwave glow that fills the universe, not concentrated in any one place, not emanating from any particular source, but distributed evenly throughout all of space. It is truly universal, existing everywhere simultaneously. The CMB is a calm, uniform background that covers the sky. No matter where you are in the universe, no matter which direction you look, you would observe the same background radiation. This uniformity is one of its most striking features, evidence of the universe's fundamental homogeneity. It is a gentle, universal whisper from the dawn of time, carrying information from the universe's earliest moments, encoded in its spectrum and its fluctuations. A message written in light, telling us about cosmic inflation, about the density of matter, about the geometry of space. The CMB is a quiet echo of the universe's birth, the reverberations of creation still perceptible today, billions of years after the event itself. Like hearing the echo of a sound long after it was made, we detect the afterglow of the Big Bang. It is a soft, ancient light that has traveled across time, from a universe 380,000 years old to a universe 13.8 billion years old. These photons have witnessed the entire history of cosmic evolution. They have seen the first stars ignite, the first galaxies form, the universe grow from simplicity to complexity. The CMB is a gentle, all-encompassing presence. It exists everywhere simultaneously, filling the entire cosmos with its subtle glow. There is no escaping it, no place in the universe free from its influence. It is as fundamental to the cosmos as space and time themselves. It is a calm cosmic background hum, the steady undertone of the universe, always present, always unchanging on human timescales. A peaceful reminder of cosmic time, of the vast ages that have passed since the universe began, of the deep history embedded in every photon of ancient light. The CMB is a fossil of the universe's hot, dense past, preserved in the patterns of microwave radiation, in the spectrum and the fluctuations, the conditions of the early universe remain visible to us. We can read this fossil like a book, extracting information about temperature, density, and composition. It is a relic of the moment when the universe became transparent. Light's liberation, the moment when photons could finally roam free, unmarred by constant collisions with electrons. This transition is recorded in the CMB, frozen in time for us to study. The CMB is a gentle, cold light that has cooled with the universe, stretched by expansion, diluted by distance, transformed from blazing heat to subtle coolness over billions of years. The cooling follows a precise mathematical law, inversely proportional to the size of the universe. It is a soft microwave glow that permeates all of space, penetrating every galaxy, every star system, every atom in existence. Nothing is exempt from its presence. Nothing exists outside its reach. It is the most pervasive phenomenon in the cosmos. The CMB is a calm, uniform background that covers the sky. From horizon to horizon, from pole to pole, the glow is nearly identical. Variations exist, but they are tiny, only 1 part in 100,000. This uniformity is a testament to the universe's remarkable symmetry. It is a gentle, universal whisper from the Big Bang, the softest of cosmic voices, speaking truths about our origins, about the nature of space and time, about the fundamental physics of the universe. To hear this whisper requires sensitive instruments and careful analysis. The CMB is a quiet echo of the universe's creation, not a loud bang, but a gentle reverberation, endlessly cycling through space and time. It echoes through billions of years, carrying its message from the beginning to the present day. It is a soft, ancient light that has traveled across time, older than any star we can observe, older than any galaxy. This light has seen the universe grow from infancy to maturity. It has witnessed cosmic history from the earliest moments to today. The CMB is a gentle, all-encompassing presence, inescapable, omnipresent, a fundamental feature of our reality. It defines the thermal state of empty space, sets the baseline temperature of the cosmos, and connects every point in the universe through its shared history. It is a calm, cosmic background hum, the deepest of all cosmic sounds, resonating through the fabric of space itself. A tranquil drone that spans the universe, that has persisted for billions of years, that will continue far into the future. The CMB is a fossil of the universe's first light, the initial illumination, the first glow, when the darkness of the early universe gave way to transparency. Before this moment, light was trapped. After this moment, light could travel freely, and the universe became visible to itself. It is a relic of the moment when the universe cooled enough for atoms to form, a critical threshold in cosmic evolution when electrons and nuclei combined to create the first neutral atoms. This moment, occurring at about 3000 Kelvin, was a phase transition in the cosmic plasma. The CMB is a gentle, cold echo of the Big Bang. From intense heat that would vaporize any material, it has cooled to just above absolute zero. From blazing energy that dominated the early universe, it has become a subtle background, barely perceptible without specialized instruments. It is a soft microwave glow that fills the universe. an ambient light so subtle, so faint, that you would never know it was there without the ability to detect microwave radiation. Yet it is there, always, filling space with ancient photons. The CMB is a calm, uniform background that covers the sky, a cosmic canvas painted with the faintest of brush strokes. The variations are so small that the early universe appears almost perfectly smooth, a sea of light with only the slightest ripples. It is a gentle, universal whisper from the dawn of time, a message encoded in microwaves, telling us about the universe's birth and evolution, about the physics of the early cosmos, about the seeds of structure that would grow into galaxies. The CMB is a quiet echo of the universe's birth, not a violent explosion in space, but a gentle expansion of space itself. The Big Bang was not an explosion that happened at a point, but an expansion that happened everywhere simultaneously. The CMB is the afterglow of that expansion. It is a soft, ancient light that has traveled across time, crossing vast cosmic distances, journeying from the edge of the observable universe to our detectors here on Earth. These photons have been traveling for longer than the Earth has existed, longer than our solar system has existed. The CMB is a gentle, all-encompassing presence. No corner of the universe is free from it. No place exists where it cannot be found. From the densest galaxy cluster to the emptiest void, the CMB is there, filling all of space with its ancient light. It is a calm cosmic background hum, a serene undertone to all of existence, the universe's oldest ambient sound. It has been humming at its characteristic frequency since the moment of recombination, and it will continue to hum far into the future, drifting peacefully through the cosmos. The CMB is a fossil of the universe's hot, dense past, a window into conditions we can barely imagine, when all of space was filled with intense energy, when temperatures exceeded those in the core of the hottest stars, when matter existed only as a plasma of elementary particles. It is a relic of the moment when the universe became transparent, the Great Liberation, the cosmic dawn, when light broke free from endless scattering and gained the freedom to travel across the cosmos unimpeded. This moment divides the opaque early universe from the transparent universe we observe today. The CMB is a gentle, cold light that has cooled with the universe. Expansion has stretched its wavelengths, lowering its temperature degree by degree over billions of years. The temperature has dropped by a factor of about 1,000 since recombination, from 3,000 Kelvin to 2.73 Kelvin today. It is a soft microwave glow that permeates all of space. Like fog filling a valley, like mist hanging in the air, the CMB fills the universe. But unlike fog or mist, it is completely uniform, the same density of photons everywhere, the same temperature in all directions. The CMB is a calm, uniform background that covers the sky. From pole to pole, from horizon to horizon, from one side of the universe to the other, the glow remains remarkably constant. Only tiny fluctuations break the uniformity. Variations so small, they require sophisticated instruments to detect. It is a gentle, universal whisper from the Big Bang, a cosmic secret shared with all who have the tools to listen, who have built the telescopes and detectors capable of receiving this ancient signal. It reveals the universe's deepest mysteries to those who study it carefully. The CMB is a quiet echo of the universe's creation, the fading reverberations of cosmic birth, still audible after all this time, still carrying information about the earliest moments. Like an archaeologist studying ancient artifacts, cosmologists study the CMB to learn about the universe's past. It is a soft, ancient light that has traveled across time, from the distant past to the present moment, from an era before stars existed to our modern era of galaxies and planets. These photons have journeyed without ceasing, without pause, without rest. The CMB is a gentle, all-encompassing presence, wrapping around galaxies like a blanket, flowing between stars like water, touching every point in space simultaneously. It is impossible to escape, impossible to avoid, a fundamental aspect of the cosmos we inhabit. It is a calm, cosmic background hum, the universe's baseline frequency, its natural resonance, a peaceful tone that has persisted since recombination. It is the gentlest of all cosmic phenomena, the softest sound in nature, humming quietly through eternity. The CMB is a fossil of the universe's first light, capturing a moment frozen in time, preserving it for billions of years, allowing us to study the universe when it was young and simple, before complexity emerged, before structure developed. It is a relic of the moment when the universe cooled enough for atoms to form, a transformation from chaos to order, from a plasma of free particles to a gas of bound structures, from opacity to transparency. This moment of recombination was a critical transition in cosmic evolution. The CMB is a gentle, cold echo of the Big Bang. What once was blazing hot, what once would have instantly vaporized any matter, is now profoundly cold, cooler than the coldest winter night on Earth. It has been cooled by eons of cosmic expansion, by the stretching of space itself. It is a soft microwave glow that fills the universe, invisible and intangible to us, undetectable without specialized equipment, yet measurable and real. A pervasive background to all existence, filling the spaces between galaxies, between stars, between atoms. The CMB is a calm, uniform background that covers the sky. Wherever you look in the cosmos, there it is, constant and reliable. A cosmic lighthouse that shines from all directions simultaneously, a universal beacon marking the edge of the observable universe in time. It is a gentle, universal whisper from the dawn of time, carrying stories from an era before stars, before complexity, before structure, from a time when the universe was simple and homogeneous, from the cosmic dark ages before the first light of stars illuminated the cosmos. The CMB is a quiet echo of the universe's birth. Like sound waves spreading from their source, like ripples emanating from a disturbance in water, the CMB spreads from the moment of recombination, carrying information about that ancient event to observers billions of years later. It is a soft, ancient light that has traveled across time, more ancient than anything else we can observe in the universe, the ultimate archaeological artifact, the oldest signal we can detect. It predates all stars, all galaxies, all planets, all structure. The CMB is a gentle, all-encompassing presence, It touches everything that exists, connects all points in space through a shared history, unites the entire universe in a common thermal background. We are all bathed in this ancient light, all connected by these primordial photons. The CMB is a soft, ancient echo from the very beginning of the universe. Imagine the first moments after creation, when all of existence was compressed into an infinitesimally small point. From that primordial state emerged this gentle radiation, this whisper from the dawn of time. It carries with it the memory of those earliest moments, encoded in its subtle patterns, preserved across billions of years of cosmic evolution. Its gentle glow is the oldest light that can be observed. Nothing we can see dates back further into the depths of cosmic history. This light began its journey when the universe was merely 380,000 years old, a mere infant compared to its current age of 13.8 billion years. These ancient photons have been traveling ever since, crossing vast expanses of space, witnessing the birth and death of countless stars, the formation of galaxies, the emergence of structure from primordial simplicity. The CMB fills every corner of space with a quiet, uniform hum. It is everywhere and nowhere, pervasive yet invisible, constant yet ever-changing as the universe expands. Like a cosmic ocean in which all matter floats, this radiation bathes everything in its subtle glow. From the densest galaxy clusters to the emptiest voids, from the heart of the Milky Way to the most distant reaches of the observable universe, the CMB is there, always present, always humming at its characteristic frequency. The CMB is a gentle reminder of the universe's hot, dense origin. Long ago, all of space was filled with intense energy and heat. Temperatures exceeded those in the cores of the hottest stars. Matter existed only as a plasma of elementary particles, unable to form stable atoms. The universe was opaque, filled with light that could not travel far before scattering. This ancient radiation reminds us of that primordial state, carrying information about conditions we can barely imagine. The CMB's temperature is nearly the same in every direction. This remarkable uniformity, varying by only 1 part in 100,000, tells us something profound about the universe's beginning. It reveals that the early cosmos was extraordinarily smooth, homogeneous on the largest scales. This uniformity is evidence of a fundamental symmetry in nature, a simplicity at the heart of cosmic complexity. Tiny variations in the CMB are the seeds of all cosmic structures. These minute fluctuations, barely perceptible even with the most sensitive instruments, held within them the blueprint for everything that would come. They determined where galaxies would form, where matter would congregate, where the great cosmic web would take shape. From quantum fluctuations smaller than an atom, structures billions of light years across would eventually emerge. The CMB is a calm, universal fingerprint of the Big Bang. Just as no two fingerprints are alike, the pattern of temperature fluctuations in the CMB is unique, a one-time signature of cosmic creation. This pattern tells us about the physics of the very early universe, about the nature of space and time, about the fundamental forces that shaped reality. It is a fingerprint left by the hand of creation itself. The CMB is a soft microwave glow that has cooled over billions of years. Once it was intense gamma radiation with wavelengths smaller than atomic nuclei. But as the universe expanded, space itself stretched, pulling the radiation along with it. Wavelengths grew longer, energy decreased, temperature dropped. What began as blazing heat has become a gentle coolness, just 2.73 degrees above absolute zero. The CMB is a quiet witness to the universe's expansion. Every photon in the cosmic microwave background has been stretched by the expansion of space. The redshift we observe in this ancient light is direct evidence that the universe has been growing larger over time. It confirms that space itself is expanding, carrying galaxies away from each other, increasing the distances between all things. The CMB is a gentle echo of the moment the universe became transparent. There was a specific moment in cosmic history called recombination, when electrons and protons combined to form neutral atoms. At this instant, the universe transformed from an opaque fog to a transparent expanse. Light could suddenly travel freely, no longer trapped by constant scattering. The CMB is the light from this moment of liberation still reaching us after billions of years. The CMB is a relic of the universe's first light. Before recombination, light was trapped, unable to travel far through the dense plasma that filled space. But at the moment of recombination, photons broke free, streaming outward in all directions. These are the first photons that could travel across the universe, the first light to illuminate the cosmos. They have been journeying ever since, and we detect them today as the cosmic microwave background. The CMB is a gentle, cold light that has traveled across time. These photons have been traveling for over 13 billion years, crossing distances so vast that light from the nearest stars takes only years to reach us. They have journeyed from the edge of the observable universe, from a time before the Earth existed, before our solar system formed, before our galaxy took its current shape. They carry with them information from an era we can never visit. The CMB is a soft, ancient glow that permeates all of space. It exists between the stars, between galaxies, between clusters of galaxies. It fills the great cosmic voids where matter is sparse. It penetrates through planets and stars, though we can only detect it clearly when we look at empty space. This glow is omnipresent, a fundamental feature of the cosmos we inhabit. The CMB is a calm, universal background that covers the sky. Look in any direction and it is there, constant and unchanging on human timescales. Point a sensitive radio telescope at any patch of sky and you will detect this ancient radiation. It covers the celestial sphere uniformly, a cosmic wallpaper that has been there since long before the Earth formed. The CMB is a gentle, universal whisper from the dawn of time. It speaks to us in the language of microwaves, in subtle temperature variations, in patterns of polarization. To hear this whisper requires sensitive instruments and careful analysis. But once decoded, it tells us about the universe's birth, about its composition, about its geometry and fate. It is a message from the beginning, written in light. The CMB is a quiet echo of the universe's birth. Like the reverberation of a sound long after it was made, the CMB is the afterglow of creation. The initial flash of the Big Bang has faded, stretched by expansion, cooled by time. But its light still reaches us, still carries information about that primordial event, still connects us to the moment when time itself began. The CMB is a soft, ancient light that has traveled across time. In its journey, It has witnessed the entire history of cosmic evolution. It has seen the first stars ignite, the first galaxies form, the first black holes consume matter. It has passed through regions where new stars are being born and regions where old stars are dying. It has traveled through the changing universe, yet remained fundamentally unchanged itself. The CMB is a gentle, all-encompassing presence. There is no escaping it, no place in the universe free from its influence. Wherever you might travel in the cosmos, the CMB would be there, surrounding you, bathing you in ancient light. It is as fundamental to the universe as space and time themselves, as pervasive as the vacuum of space. The CMB is a calm cosmic background hum. It hums at a frequency characteristic of its temperature, a note so low it is far below what human ears could hear. But translated into temperature, into the energy of photons, this hum is detectable. It is the baseline noise of the universe, the fundamental thermal state of empty space, the floor below which temperatures cannot naturally fall in our current cosmic epoch. The CMB is a fossil of the universe's hot, dense past. Like a fossil preserved in stone, the CMB preserves information about conditions long ago. Paleontologists study ancient fossils to learn about prehistoric life. Cosmologists study the CMB to learn about the prehistoric universe. Both are reading the record of the past. Both are interpreting evidence left behind by ancient events. The CMB is a relic of the moment when the universe became transparent. This moment, this transition from opacity to transparency, is captured in the cosmic microwave background. Before recombination, the universe was like a thick fog, impossible to see through. After recombination, it became clear and light could travel freely. The CMB marks this transition, this moment when the universe revealed itself. The CMB is a gentle, cold light that has cooled with the universe. As space expands, it does not just carry galaxies apart, it also stretches the wavelength of light itself. Every photon traveling through expanding space has its wavelength increased, its energy decreased. The CMB has been cooled by this process for billions of years, stretched from high-energy radiation to gentle microwaves. The CMB is a soft microwave glow that permeates all of space. Microwaves are a form of electromagnetic radiation, similar to visible light but with longer wavelengths. The CMB exists primarily in the microwave part of the spectrum because of the cosmic expansion that has stretched its wavelength. If we had eyes that could see microwaves, the entire sky would glow with this ancient light. The CMB is a calm, uniform background that covers the sky. Its uniformity is one of its most striking features. Variations exist, but they are tiny, requiring sensitive instruments to detect. This uniformity tells us that the universe was once in a state of thermal equilibrium, with all regions at the same temperature, all connected by a shared history. The CMB is a gentle, universal whisper from the Big Bang. The Big Bang was not an explosion in space, but an expansion of space itself. It happened everywhere simultaneously, not at a single point. The CMB emerged from every point in the universe at the moment of recombination, and we detect it coming from all directions because we are surrounded by the regions that emitted it. The CMB is a quiet echo of the universe's creation. Creation in this context means the beginning of space, time, matter, and energy as we know them. Before the Big Bang, there was no before in any meaningful sense, because time itself began with the Big Bang. The CMB is an echo from the earliest moments when time had meaning, when the universe as we understand it came into being. The CMB is a soft, ancient light that has traveled across time. Time and space are intertwined in Einstein's relativity. To look far into space is to look back in time, because light takes time to travel. The CMB comes to us from the farthest reaches of the observable universe, from a time when the universe was young. In observing it, we are looking backward through time, witnessing the ancient past. The CMB is a gentle, all-encompassing presence. It surrounds us completely, coming from all directions at once. We are immersed in it, floating in an ocean of ancient photons. Every cubic centimeter of space contains about 400 CMB photons on average, left over from the Big Bang, traveling through space, filling the universe with their subtle presence. The CMB is a calm cosmic background hum. This hum has been present since recombination, and it will continue far into the future. As the universe continues to expand, the CMB will continue to cool, its temperature dropping ever closer to absolute zero. But it will remain, always humming, always present, a permanent feature of the cosmos. The CMB is a fossil of the universe's first light. First light has a special meaning here, referring not to the first light ever created, but to the first light that could travel freely through space. Before recombination, light was trapped. After recombination, light was free. The CMB represents this first free light, these first photons, to journey across the cosmos unimpeded. The CMB is a relic of the moment when the universe cooled enough for atoms to form. At high temperatures, electrons have too much energy to be captured by atomic nuclei. But as the universe cooled through expansion, electrons slowed down. Eventually, at around 3000 Kelvin, they were slow enough to be captured, forming the first neutral atoms. This moment changed everything, allowing light to travel freely for the first time. The CMB is a gentle, cold echo of the Big Bang. An echo is a reflected sound, but in a broader sense, it is any signal that persists after the original event. The CMB is an echo in this sense, a signal that has persisted for billions of years, carrying information about the event that created it. It is the fading reverberation of cosmic birth. The CMB is a soft microwave glow that fills the universe. To fill means to occupy completely, and the CMB does exactly that. There is no volume of space, however large or small, that does not contain CMB photons. From the space between your atoms to the space between galaxy clusters, the CMB is there, filling everything with ancient light. The CMB is a calm, uniform background that covers the sky. The sky, in this context, means the entire celestial sphere, everything we might observe in any direction. The CMB covers all of it, a spherical shell of ancient light surrounding us. We sit at the center of our observable universe, and the CMB forms the backdrop against which all other cosmic phenomena appear. The CMB is a gentle, universal whisper from the dawn of time. The dawn of time is a poetic way of describing the earliest moments of the universe when time itself began. The CMB comes from an era just 380,000 years after this beginning, incredibly early in cosmic history. It whispers to us across billions of years, carrying messages from that ancient dawn. The CMB is a quiet echo of the universe's birth. Birth implies a beginning, a coming into existence. The universe had such a beginning in the Big Bang. Before this, there was no space, no time, no matter, no energy, as we understand them. The CMB echoes from just after this birth, from the earliest moments when the universe became recognizable as a physical system. The CMB is a soft, ancient light that has traveled across time. The journey of this light spans the vast majority of cosmic history. It has been traveling for more than 13 billion years, across distances measured in billions of light years. To comprehend such scales requires stretching our imagination to its limits, contemplating durations and distances far beyond everyday experience. The CMB is a gentle, all-encompassing presence. All-encompassing means including everything, leaving nothing out. The CMB truly encompasses all of observable space, existing everywhere simultaneously. It is impossible to escape, impossible to avoid. Wherever observers might exist in the universe, they would detect the same background radiation, the same ancient glow. The CMB is a calm cosmic background hum. Background implies something that is always present but often unnoticed, like background noise in a busy room. The CMB is the background to all cosmic phenomena, the baseline against which all other signals are measured. It sets the minimum temperature of space, the thermal floor of the universe. The CMB is a fossil of the universe's hot, dense past. Hot and dense are relative terms, but the early universe was both in the extreme. Temperatures were billions of degrees, densities were enormous. As the universe expanded, it cooled and became less dense. But the CMB preserves a record of that earlier state, allowing us to study conditions that no longer exist anywhere in the cosmos. The CMB is a relic of the moment when the universe became transparent. Transparency is a property we often take for granted, but it is not universal. The early universe was opaque because free electrons scattered photons constantly. When electrons combined with nuclei to form atoms, this scattering stopped and the universe became transparent. This transition is preserved in the CMB, which consists of photons released at that exact moment. The CMB is a gentle, cold light that has cooled with the universe. Cooling is a process, not a one-time event. The CMB has been cooling continuously for over 13 billion years as the universe expands. It began at about 3000 Kelvin and has cooled to about 2.73 Kelvin today. This cooling will continue indefinitely as expansion proceeds, with the temperature approaching ever closer to absolute zero. The CMB is a soft microwave glow that permeates all of space. To permeate means to spread throughout, to penetrate completely. The CMB does this literally, existing in every region of space, filling every volume, touching every point. It is the most widespread phenomenon in the universe, more pervasive than matter, more universal than galaxies. The CMB is a calm, uniform background that covers the sky. Calm suggests peace, tranquility, absence of disturbance. The CMB is calm in the sense that it is stable, unchanging on human timescales, predictable in its properties. It has been there for billions of years, and it will remain for billions more, a constant presence in an ever-changing universe. The CMB is a gentle, universal whisper from the Big Bang. Universal means applying to all, relevant everywhere. The CMB is universal in multiple senses. It fills the entire universe. It is observed from all locations. It carries information about the universe as a whole. It is the most universal signal we can detect, a message from creation itself. The CMB is a quiet echo of the universe's creation. Quiet suggests subtlety, softness, something easily overlooked. The CMB is quiet in the sense that it requires sensitive instruments to detect. It does not announce itself loudly, but once detected, once carefully studied, it reveals profound truths about the cosmos, about our origins, about the fundamental nature of reality. The CMB is a soft, ancient light that has traveled across time. Soft light is gentle light, not harsh or intense. The CMB is soft because it has been cooled by expansion, redshifted to longer wavelengths, transformed from high-energy radiation to gentle microwaves. Its softness belies its importance. Its gentleness masks its power to illuminate cosmic history. The CMB is a gentle, all-encompassing presence. Presence suggests existence, being there, occupying space. The CMB has presence throughout the universe, existing everywhere, filling all of space. Its presence is inescapable, unavoidable, a fundamental aspect of the cosmos we inhabit. We live within it, surrounded by ancient light. The CMB is a calm cosmic background hum. Cosmic refers to the universe as a whole, to the largest scales of space and time. The CMB is cosmic in the deepest sense, arising from the entire universe, carrying information about the cosmos as a whole, connecting all regions of space through a shared thermal history. The CMB is a fossil of the universe's first light. Fossils are typically thought of as biological, the preserved remains of ancient life. But the concept extends beyond biology. A fossil is any preserved record of the past, and the CMB is exactly that, a record of the universe's earliest observable moments, preserved in the patterns of radiation we detect today. The CMB is a relic of the moment when the universe cooled enough for atoms to form. Relics are objects surviving from an earlier time, often venerated for their historical significance. The CMB is the ultimate cosmic relic, surviving from the earliest accessible moment in cosmic history, carrying information about that ancient time to the present day. The CMB is a gentle, cold echo of the Big Bang. Cold is relative, defined by context. The CMB at 2.73 Kelvin is cold by most standards, far below the freezing point of water, approaching the absolute minimum possible temperature. Yet it fills all of space with its presence, defining the thermal state of the universe. The CMB is a soft microwave glow that fills the universe. Glow suggests emission of light, a radiance from within. The CMB does glow in this sense, though not in visible light. It glows in microwaves, filling the universe with electromagnetic radiation, creating a background radiance that pervades all of space. The CMB is a calm, uniform background that covers the sky. Uniform means the same everywhere, consistent, homogeneous. The CMB is remarkably uniform, with variations of only one part in 100,000. This uniformity is evidence of the universe's fundamental simplicity at early times, before structure emerged, before complexity developed. The CMB is a gentle, universal whisper from the dawn of time. Whisper implies softness, subtlety, something spoken quietly. The CMB whispers in the sense that it is faint, requiring sensitive instruments to hear. But for those who can listen, it speaks volumes about cosmic history, about the physics of the early universe, about our ultimate origins. The CMB is a quiet echo of the universe's birth. Birth is a beginning, but it is also a transformation, a coming into being of something new. The Big Bang was the birth of the universe in this sense, the moment when space, time, matter, and energy came into existence. The CMB echoes from just after this birth, from the universe's infancy. The CMB is a soft, ancient light that has traveled across time. To travel across time is to bridge the gap between past and present. The CMB does this literally, originating in the distant past and reaching us in the present. In detecting it, we establish a connection across billions of years, touching the ancient past through observation in the present. The CMB is a gentle, all-encompassing presence. To encompass means to surround, to enclose, to include within. The CMB encompasses all of space, surrounding everything that exists, including all matter and energy within its domain. We exist within this encompassing presence, immersed in ancient radiation. The CMB is a calm, cosmic background hum. Hum suggests a continuous sound, steady and persistent. The CMB hums in this metaphorical sense, a steady signal that never stops, that has persisted for billions of years, that will continue far into the future. It is the steady drone of the cosmos. The CMB is a fossil of the universe's hot, dense past. Past can be recent or ancient, but the CMB's past is truly ancient, dating back more than 13 billion years. This past was dramatically different from the present, hotter, denser, simpler. The CMB preserves a record of this alien epoch, allowing us to study a universe very different from the one we observe today. The CMB is a relic of the moment when the universe became transparent. Moments can be brief or extended, but this moment of recombination occurred over a relatively short period in cosmic terms. During this moment, the universe transitioned from opaque to transparent, and the CMB photons were released. This brief period in cosmic history had permanent consequences, creating the radiation we observe today. The CMB is a gentle, cold light that has cooled with the universe. Light is often associated with warmth, but the CMB defies this expectation. It is light that is cold, electromagnetic radiation at a temperature just above absolute zero. This cold light fills the universe, setting the baseline temperature of space itself. The CMB is a soft microwave glow that permeates all of space. Space itself is not empty, but filled with various forms of energy and fields. The CMB is one of these, filling space with photons, with electromagnetic energy. It is impossible to find a region of space completely empty of CMB photons. The CMB is a calm, uniform background that covers the sky. Sky in cosmology refers to the entire celestial sphere, everything we can observe in all directions. The CMB covers all of this, providing a backdrop against which all other astronomical objects appear. It is the canvas on which the universe paints itself. The CMB is a gentle, universal whisper from the Big Bang. The Big Bang was neither gentle nor a whisper, but an event of unimaginable energy and violence. Yet the CMB, its afterglow, is both gentle and a whisper, cooled and softened by billions of years of expansion, transformed from intense radiation to subtle glow. The CMB is a quiet echo of the universe's creation. Creation can be sudden or gradual, violent or gentle. The Big Bang was sudden and violent, but the CMB, its echo, is quiet and gentle. This transformation from violence to tranquility reflects the evolution of the universe itself, from chaos to order, from simplicity to complexity. The CMB is a soft, ancient light that has traveled across time. Ancient implies great age, belonging to a distant past. The CMB is ancient in the deepest sense, originating from the earliest accessible moment in cosmic history. Its age is measured in billions of years, a span of time difficult for human minds to fully comprehend. The CMB is a gentle, all-encompassing presence. All-encompassing leaves nothing out, includes everything. The CMB truly encompasses all of space as we can observe it, filling the entire observable universe with its presence. Beyond the observable universe, we presume it continues, filling all of space throughout the cosmos. The CMB is a calm cosmic background hum. Calm implies stability, lack of agitation or disturbance. The CMB is calm in its consistency, in its uniform distribution, in its predictable properties. It is a stable background against which the dynamic universe evolves, a calm presence in a changing cosmos. The CMB is a fossil of the universe's first light. First light is a phrase loaded with significance in astronomy. It marks beginnings, the start of illumination, the moment when darkness gives way to light. The CMB represents this first light in the deepest cosmic sense, the first electromagnetic radiation that could travel freely through space. The CMB is a relic of the moment when the universe cooled enough for atoms to form. Atoms are the building blocks of matter as we know it, the basis of chemistry, the foundation of complexity. Before atoms formed, the universe was simpler, composed only of elementary particles. The formation of atoms marked a transition to greater complexity, and the CMB marks this transition. The CMB is a gentle, cold echo of the Big Bang. Echoes fade with time, growing fainter and fainter. In a sense, the CMB is a fading echo, cooled by expansion, dimmed by distance. Yet it persists, still detectable, still carrying information. It is an echo that will never completely fade, continuing indefinitely as the universe expands. The CMB is a soft microwave glow that fills the universe. Filling implies completeness, leaving no gaps or empty spaces. The CMB fills in exactly this sense, existing everywhere, occupying all volumes, leaving no region untouched. It is the ultimate space-filling phenomenon. The CMB is a calm, uniform background that covers the sky. Background suggests something behind other things, a foundation on which other phenomena appear. The CMB is the ultimate background in cosmology, the farthest thing we can see, the earliest signal we can detect. All other astronomical objects appear against this background. The CMB is a gentle, universal whisper from the dawn of time. Dawn represents beginning, the transition from darkness to light, the start of a new day. The cosmic dawn was the period after recombination when the first stars began to form. But the CMB predates even this, coming from just before the cosmic dawn, from the moment when the universe became transparent. The CMB is a quiet echo of the universe's birth. Birth involves pain and struggle, but also joy and new beginning. The Big Bang was not a birth in the biological sense, but it shares the quality of being a beginning, a coming into existence of something new. The CMB echoes from this cosmic birth, this moment of universal genesis. The CMB is a soft, ancient light that has traveled across time. Light travels at a finite speed, taking time to cross distances. The CMB has been traveling for more than 13 billion years, covering distances measured in billions of light years. This journey across time and space connects the ancient past to the present moment. The CMB is a gentle, all-encompassing presence. Presence can be comforting or unsettling, but the CMB's presence is simply a fact of cosmic existence. It is always there, surrounding everything, connecting all regions of space through shared radiation. This presence is inescapable, universal, fundamental. The CMB is a calm cosmic background hum. Background hum suggests something barely noticed, present but not demanding attention. The CMB is exactly this, a subtle signal that requires effort to detect, yet once detected, reveals profound truths about the universe. It hums quietly in the background of cosmic phenomena. The CMB is a fossil of the universe's hot, dense past. Fossils allow us to study the past directly, to see evidence of conditions that no longer exist. The CMB serves this function in cosmology, allowing us to study the early universe directly, to observe conditions that disappeared billions of years ago. It is our window into the deep past. The CMB is a relic of the moment when the universe became transparent. Becoming implies change, transformation, transition from one state to another. The universe's transition from opaque to transparent was one of the most important events in cosmic history. It allowed light to travel freely. It created the CMB. It marked the end of the cosmic dark ages. The CMB is a gentle, cold light that has cooled with the universe. Cooling is inevitable in an expanding universe. As space grows larger, energy becomes more dilute, temperatures drop. The CMB has participated in this cosmic cooling for billions of years, its temperature dropping continuously as the universe expands. The CMB is a soft microwave glow that permeates all of space. Permeation is complete penetration, thoroughgoing diffusion. The CMB permeates space in the fullest sense, existing everywhere, filling all volumes, touching all points. There is no escaping it, no hiding from it, no place free from its presence. The CMB is a calm, uniform background that covers the sky. Covering suggests protection, concealment, or simply presence everywhere. The CMB covers the sky in the sense of being visible with appropriate instruments in all directions, forming a spherical shell of radiation around any observer in the universe. The CMB is a gentle, universal whisper from the Big Bang. Whispers carry secrets, intimate communications, messages meant to be heard by those who listen carefully. The CMB whispers cosmic secrets to those who study it carefully, revealing truths about the universe's beginning, its composition, its fate. The CMB is a quiet echo of the universe's creation. Creation ex nihilo, creation from nothing, is a concept that challenges our intuition. Yet the Big Bang represents something like this: the emergence of space, time, matter, and energy from a state we cannot fully describe. The CMB echoes from just after this creation event. The CMB is a soft, ancient light that has traveled across time. Time travel, in the sense of journeying to the past or future, may be impossible for matter. But light travels through time in a different sense, originating in the past and arriving in the present. The CMB has traveled through time in exactly this way, bridging billions of years. The CMB is a gentle, all-encompassing presence. Encompassing presence suggests something that surrounds and includes everything. The CMB does this literally, existing throughout all of observable space, surrounding all matter and energy, including all structures within its domain. We are embedded in this presence. The CMB is a calm, cosmic background hum. Cosmic background is a technical term in astronomy, referring to radiation that fills the universe uniformly. The CMB is the ultimate cosmic background, the most pervasive radiation field in the cosmos, filling all of space with its gentle glow. The CMB is a fossil of the universe's first light. First light represents a beginning, an illumination, a transition from darkness. The CMB represents the first light that could travel freely, the first photons to stream across the cosmos unimpeded. It marks the moment when the universe became visible to itself. The CMB is a relic of the moment when the universe cooled enough for atoms to form. Formation of atoms was a critical threshold in cosmic evolution. It marked the transition from plasma to gas, from opacity to transparency, from simplicity to the possibility of greater complexity. This moment is preserved in the CMB. The CMB is a gentle, cold echo of the Big Bang. The Big Bang echo is not an acoustic echo, but an electromagnetic one, radiation that persists after the event. This echo has been traveling through space for billions of years, cooled and stretched by expansion, but still carrying information about its origin. The CMB is a soft microwave glow that fills the universe. The universe is vast beyond comprehension, yet the CMB fills all of it that we can observe. From the nearest star to the most distant galaxy, from the densest cluster to the emptiest void, the CMB is there, filling everything with ancient radiation. The CMB is a calm, uniform background that covers the sky. The uniformity of the CMB is remarkable, almost unnatural in its perfection. This uniformity tells us that the early universe was in thermal equilibrium, that all regions were in causal contact, that the cosmos was once much smaller and simpler than it is today. The CMB is a gentle, universal whisper from the dawn of time. Dawn of time is poetic language for the beginning of the universe, the moment when time itself began. The CMB comes from just after this beginning, from the earliest moments when the universe became observable. It whispers to us across the ages. The CMB is a quiet echo of the universe's birth. Birth implies potential, the promise of growth and development. The universe at the moment of CMB emission was simple and homogeneous, but it held within it the potential for all future complexity. The seeds of galaxies, stars, and planets were already present as tiny fluctuations. The CMB is a soft, ancient light that has traveled across time. Traveling across time is traveling through history, witnessing the evolution of the cosmos. The CMB has witnessed everything that has happened in the universe since recombination, though it carries information only about its own origin, not about events it has passed through. The CMB is a gentle, all-encompassing presence. All-encompassing means total, complete, leaving nothing out. The CMB's presence is total in this sense, filling all of space, existing everywhere, touching everything. It is the most universal presence in the cosmos. The CMB is a calm, cosmic background hum. The cosmic background hum has been present for over 13 billion years, and it will continue for trillions of years to come. As the universe continues to expand, this hum will grow ever quieter, ever cooler, but it will never completely disappear. The CMB is a fossil of the universe's hot, dense past. The past is another country, as the saying goes, and the universe's past is truly alien. Conditions in the early universe were so different from today that they challenge our imagination. The CMB is our only direct link to this alien epoch, our fossil record of a bygone age. The CMB is a relic of the moment when the universe became transparent. Transparency allows us to see through, to observe what lies beyond. The universe's becoming transparent allowed light to travel across space, allowed structures to become visible, allowed observation itself to become possible. The CMB marks this crucial transition. The CMB is a gentle, cold light that has cooled with the universe. The universe continues to cool, and the CMB continues to cool with it. Billions of years from now, the CMB will be even colder than it is today, eventually approaching absolute zero as the universe expands toward infinity. The CMB is a soft microwave glow that permeates all of space. Space is the arena in which all cosmic events unfold, the stage on which the universe performs. The CMB fills this stage completely, providing a background glow that illuminates in a subtle way all of cosmic existence. The CMB is a calm, uniform background that covers the sky. The sky is the limit, as the saying goes, but for the CMB, there is no limit. It extends to the edge of the observable universe, to the horizon of our ability to see. It is the ultimate background, the farthest and earliest thing we can observe. The CMB is a gentle, universal whisper from the Big Bang. The Big Bang whisper has been traveling through space for over 13 billion years, yet it still reaches us today. This whisper will continue far into the future, long after our sun has died, long after our galaxy has merged with others, carrying its message through the ages. The CMB is a quiet echo of the universe's creation. Creation is the ultimate mystery, the question of how something came from nothing or how our universe came to exist. The CMB cannot answer this ultimate question, but it can tell us about the very early universe, about conditions just after creation, about the first observable moments. The CMB is a soft, ancient light that has traveled across time. Ancient civilizations looked at the stars and wondered about their origins. We look at the CMB and see our cosmic origins, the earliest light from the universe's infancy. This ancient light connects us to the deepest past, to the moment of cosmic genesis. The CMB is a gentle, all-encompassing presence. Presence in the moment is a concept from mindfulness, being fully aware of the present. The CMB has a different kind of presence, existing everywhere in space, always in the present moment, yet carrying information from the ancient past. It is simultaneously past and present. The CMB is a calm cosmic background hum. The background hum is so constant, so unchanging on human timescales that we can use it as a reference point. We measure the motion of our galaxy against the CMB, detecting our movement through space by the Doppler shift it creates in this ancient radiation. The CMB is a fossil of the universe's first light. First light is often celebrated in astronomy, marking the beginning of a telescope's operations or a mission's success. But the CMB is the ultimate first light, the first light in cosmic history, the first electromagnetic radiation to travel freely through space. All other first lights pale in comparison. The CMB is a relic of the moment when the universe cooled enough for atoms to form. Atoms are the alphabet of chemistry, the letters from which the book of molecular complexity is written. Before atoms, chemistry was impossible. The formation of atoms opened the door to all future chemical evolution, to the eventual emergence of life itself. The CMB is a gentle, cold echo of the Big Bang. The Big Bang was the hottest moment in cosmic history, a state of unimaginable energy density. The CMB, its echo, is now among the coldest things in the universe, cooled by expansion to just above absolute zero. This transformation from hottest to coldest reflects the evolution of the cosmos. The CMB is a soft microwave glow that fills the universe. Microwaves are familiar to us from microwave ovens and wireless communication, but the CMB operates at different frequencies. It peaks at about 160 gigahertz in the microwave region of the spectrum, invisible to our eyes but detectable by radio telescopes. The CMB is a calm, uniform background that covers the sky. The calmness of the CMB is deceptive, suggesting a static, unchanging universe. But the universe is dynamic, constantly evolving, expanding, changing. The CMB is calm only in the sense that it changes slowly on human time scales, imperceptibly to direct observation. The CMB is a gentle, universal whisper from the dawn of time. Time's dawn was the moment when causality began, when events could influence other events, when history became possible. Before the Big Bang, if before has any meaning, there was no time. The CMB comes from just after time's dawn, from the first moments of cosmic history. The CMB is a quiet echo of the universe's birth. Quiet can mean peaceful, but it can also mean faint, barely audible. The CMB is both. It is peaceful in its uniformity, in its calm presence. It is faint in its signal strength, requiring sensitive instruments to detect. Both meanings apply to this cosmic whisper. The CMB is a soft, ancient light that has traveled across time. Light defines our cosmic horizon, limiting what we can see to what light has had time to reach us from. The CMB defines our ultimate horizon, the edge of the observable universe in time. We cannot see past the CMB to earlier moments because the universe was opaque before recombination. The CMB is a gentle, all-encompassing presence. All-encompassing presence suggests something inescapable, something that includes everything within its scope. The CMB encompasses all of observable space, includes all regions within its domain. To exist in this universe is to exist within the CMB's presence. The CMB is a calm cosmic background hum. The cosmic background is sometimes called the cosmic hiss, like radio static. This hiss is the sound of the universe itself, the noise generated by countless photons arriving randomly at our detectors. It is the sound of creation, the noise of the Big Bang, still audible billions of years later. The CMB is a fossil of the universe's hot, dense past. Hot and dense describe extreme conditions, states of matter and energy far from our everyday experience. The early universe was both hotter and denser than anything we can create in laboratories. The CMB preserves evidence of these extreme conditions, allowing us to study physics at energies and densities we cannot otherwise access. It is our laboratory for studying the ultimate extremes, our window into conditions at the edge of the possible, our connection to a universe that no longer exists except in this ancient light, this gentle whisper from the very beginning of everything we know.